The heading is here, drift velocity of electrons. Drift velocity. Actually, simple definition I have written first, and I will explain the concept of drift velocity later, because in exam question come like that, okay, what is drift velocity? So drift velocity in case of metallic conductor, the average velocity of free electrons in metallic conductor under the action of electric field applied across the conductor is called drift velocity. Actually, in metallic conductor, free electrons are there in big number. They keep on moving randomly. And for a free conductor, when there is no electric field applied across it, no current flows through the conductor. But when we apply electric field across conductor, the electrons move with an average speed, average velocity, which is called drift velocity. So now I will explain the concept of drift velocity. But first of all, I want to tell you that in exam question come of 1 mark. What do you mean by drift velocity? So it is the average velocity of free electrons in metallic conductor under the action of applied electric field. Now I will establish the relation between drift velocity and electric field applied. So relation between drift velocity and electric field. It is the case of metallic conductors. In a metallic conductor, there are free electrons. From the theory of metallic bond, in metal there are like atoms, same atoms, like copper. Copper has two valence electrons. Those valence electrons are lost by copper, and those 3 electrons make electron C. And this electron C and positive ions, which are called kernels, have a force of attraction which is very strong, and metals are hard. But in a free conductor, the velocity of electrons are quite random, and magnitude of these velocities depends upon temperature, and due to collision their velocities are random. These velocities are called thermal velocities. So I write here, in a free conductor, free means when no field applied across it, free electrons move randomly. Hence, the magnitude of the velocity of free electrons depends on the temperature. Hence, these velocities velocity of electrons are called thermal velocity. टेम्परेचर डिपेंडेंट है वो वेलोसिटी, है ना. Has the temperature random velocity magnitude will increase. Now, since in free conductor and in case of free conductor, average of these thermal velocities is across any cross section of conductor, across any cross section area of conductor is 0. So if vector u1 comma u2 comma u3 so on up to un be the thermal velocities of electrons across a given cross section area, then u1 plus u2 plus u3 plus so on up to plus un upon n equal to 0. Average of velocity of electron across any cross section is 0. That is why no current flows, because that by divergent current is the net flow of charge. Now when we apply electric field, suppose like this, it is a conductor here, and now we apply here by connecting a battery opposite, we apply electric field here. Equation 1. Now when we apply an external electric field E, when an electric field vector E is applied, across the conductor, every free electron experiences a force F equal to minus E into capital E. Electric field E is the force per charge, and if there is charge minus E, so this is the force on each electron. Minus sign indicates the direction of force and electric field are opposite. So due to this force, acceleration produced is vector A equal to minus E into E upon N. A equal to F by M, Newton's second law. So this is due to this acceleration, every electron start gaining velocity in the direction opposite to electric field. Okay, so you can say here, due to this acceleration, every electron starts gaining velocity in the direction opposite to electric field. You must understand here, this A, acceleration A, opposite direction of electric field. Now at any stand, suppose U1 is this, electric field this way, so this will start gaining velocity in this direction. So if t that in time t, at, this will be velocity gain v1. Because the electron initially are in random motion and acceleration produced by the force due to electric field is opposite to electric field. Due to large number of free electrons there may occur collision of this electron, with other electron or positive ion also. If small t1 is the time interval between two successive collisions, if small t1 be the time interval between two successive collisions, then velocity gained by electron is given by V1 equal to U1 plus minus E into E upon M into T1. Here we have write V equal to U plus AT. In class 11 we have learnt equation of uniformly extended motion. Similarly, for other electrons, if T1 like T1 is this, so there are big number of electrons. For other electrons, we also can write like this, and hence for other electrons, V2 is equal to U2 plus minus E into E upon M into T2, V3 U3 plus minus E into capital E upon M into P3 and so on. Vn Un plus minus E into E upon M into Pn. So different electrons will have different time of collision, and hence the velocity gained by them between two such collisions are given by the equations, and average of these velocities is called average of the velocities gained by different electrons is called drift velocity. Vd. It is very ridiculous actually, a problem. Student, I don't understand why they don't follow the norms of writing. Here it is after D and D suffix. But in while examining copies, I have noted they write D small and D so long. This is wrong to write. This is suffix here. So please maintain the decorum of writing. So what is Vd? Average of all these velocities. कैसे लिखेंगे भाई? So Vd is equal to V1 plus V2 plus V3 plus so on plus Vn upon N. Now using the equation we can write U1 plus U2 plus U3 plus Un अपॉन एन. उन सभी को जोड़ दिया हमने जो लिखी थी अभी, और प्लस माइनस ई इंटू ई अपॉन एम कॉमन, और T1 प्लस T2 प्लस T3 अप टू प्लस Tn अपॉन एन. वो जो सब इक्वेशन लिखी थी उन सबको उनके U1 U2 U3 जोड़े, add k and T1 T2. Now from equation 1, using equation 1, this average is 0, so V is equal to 0 plus minus E into E upon M into, I write here tau, where tau is equal to T1 plus T2 plus T3, so on up to plus Tn upon n. Or we can write it as Vd equal to minus E into E upon M into tau. Tau is here, where tau is average relaxation time. Relaxation time, यानी कि average time for which electron move freely between two successive collisions. This is the average. Okay. So this is the relation of drift speed velocity with the electric field. Minus sign indicates that Vd is a positive applied electric field. Now magnitude of this Vd is equal to Vd. We can write like this. Is simply E into E upon M into tau. If in this figure L is the length of conductor and V is the potential difference. Okay. So E equal to V upon L. So here Vd come out to be equal to E upon N into V upon L into tau also. Basically, from this formula we can say by E by M तो ratio of charge to mass of electron है. It is constant for every metal, every conductor. For a given conductor, longer the length, lesser the drift speed. Just I explained you while explaining the dependent of resistance on geometrical sequence. As longer the length of wire, greater the resistance. This is because of, we will prove it, it has relation with that one. So, question comes in the paper also. Okay, if we increase the length of conductor, then drift speed will increase, decrease. Potential difference, like this. So, here this is the relation of drift speed velocity with this, and here this modulus of V is called drift speed. E is the magnitude of charge of electron, M is the mass of electron, V is the potential difference and the length. So the relation time. In next video, I will establish relation between electric current and drift speed. Thank you.